Hi all, let's continue with the sign magnitude multiplication. In today's lecture, we are going to see an example problem on how to perform a multiplication operation on a sign magnitude data. So this is a flow chart. We have already discussed about this flow chart where you have a multiplicand stored in your B register and multiplier in Q, and QS holds the sign bit of your multiplier and BS holds the sign bit of your multiplicand. You need to first assign your product will be stored in A and Q registers, and AS and QS represents the sign bits of A and Q registers. So you need to first assign the resultant sign of your product. For that you are performing an XOR operation on the sign of the multiplicand and multiplier bits. So that will give you the sign of your resultant product. Next, you are going to initialize the values of A, E, and sequence counter. A is a temporary register that is initialized to all zeros initially, and E is a flip-flop, extended flip-flop, which is initialized to the value 0. And sequence counter is initialized to a number which is equal to the number of bits of your multiplier. Since along with the sign bit, you consider the number of bits of the multiplier as n, but you have to consider only the magnitude part of your multiplier, so which represents n minus 1 bits. Okay. Next is the Qn. You are going to check the rightmost bit of your multiplier or the least significant bit of your multiplier, qnth bit, that is represented by Qn. So if Qn is equals to 0, then you have to perform a shift right, logical shift right operation on the contents of E register, E flip flop, A register and Q register. And then after performing a shift right, you're going to decrement your sequence counter by 1, and you're going to check the value of the sequence counter. So the sequence counter will be decremented after each and every operation. If the sequence counter is equal to 0, that represents the end of your multiplication and your product is stored in A and Q registers. Partial product, so half of your product is stored in A register and Q. If you combine, you get your entire product. If sequence counter is not equal to 0, you are going to again go to the loop and start the process. This will be continued until your sequence counter reaches 0. At the same time, if the qnth bit is equals to 1, you have to perform an addition operation on the contents of register A and B, and the result is stored in E and A register. E flip flop, which stores the carry bit, and A stores your sum. And after performing an addition, you have to again perform a shift right operation on the contents of E, A and Q and decrement the sequence counter by 1. So this is, and then you are going to check the sequence counter. Based on the value of the sequence counter, we are going to decide whether we are going to go back to the loop or you have to stop the multiplication operation. So this is the flowchart of your multiplication. Now let us see an example. First, we'll take an example of how to perform a normal binary multiplication on two operands 23 into 19, where 23 is my multiplicand and 19 is my multiplier. So we have to first convert this into a binary form. So if you take this 1 0 for 23, the binary equivalent is 1 0 1 1 1. So this is my multiplicand. And multiplier is represented as 1 0 0 1 1, and this is a multiplier. So if I multiply this 1 0 1 1 1 into 1 0 0 1 1. So since we are having a first bit as 1, I am going to repeat the multiplicand. Next is also 1 1 1 1 0 1. Next I have 0. So all zeros. I am copying down all zeros. Next is also 0. So 0 0 0 0 0. Next is a 1. So 1 1 1 0 1. So now I have to add all these partial products to get the actual product. So it becomes 1. So 1 plus 1 becomes 1 0. It becomes 1 plus 1, 1 0 plus 1, it becomes 1 1. So next 1 plus 1, this is your carry bit. So 1 plus 1, it becomes 1 0. So here I have a carry 1. So 1 plus 1 1 0, 1 0 plus 1 1 1. So again I have a carry. So 1 plus 1 1 0, 1 0 plus 1 1 1. Again I have a carry. So 1 plus 1, it is 1 0 and 1 1. So this is my actual product. So if you and coming to the sign of 23 is positive. So it is represented by 0, and 19 is also positive 0. So 0 XOR 0, my sign bit will also be 0. So if I convert this into a decimal representation, it gives me 4 plus 437. This is my actual product. Right? Now we'll take the same example and perform a sign magnitude multiplication using flowchart. So 23 into 19, where 23 is my multiplicand. So my B register holds the multiplicand 23. I'm converting it into a binary number which is 10111. And Q register holds the multiplier which is 19, which is represented as 10011. Okay, this is the first step. Second step is storing the sign bits of multiplicand and multiplier. BS is used to store the sign bit of the multiplicand. Since both are positives, I am making BS as 0 and QS as 0. Now, second step is you need to assign the sign for your resultant product AS and QS. So you have to perform XOR of QS XOR BS. So QS XOR BS is equals to 0 XOR 0, that is equal to 0. So AS is 0 and QS also is 0, right? So next you have to also initialize the values of A. So you have to initialize A to all zeros. 5-bit representation I am taking, so I am giving 5 zeros. And E which is an extended flip-flop which stores only 1 bit, so it is 0. And sequence counter has to be initialized to the number equal to the number of bits of your magnitude part of your multiplier. So without a sign bit, how many bits you are representing the magnitude? 5 bits. So sequence counter will be 5. So this is second step. Next, we'll move with the third step. So we have to take Qn. Qn represents the rightmost bit of Q. Rightmost bit of register Q is represented by Qn. So what is your Q? 10011. So what is your Qn? This one. This is 1. So you are checking the value of Qn. So Qn is equals to 1. So what you have to do? Check Qn. So it is equal to 1. So what you have to perform? You have to perform EA implies A plus B first. So what is the value of A? 0 0 0 0 0. It is initialized to all zeros. Plus what is the value of B? 1 0 1 1 1. So perform an addition which will give you 1 1 1 0 1. So this is your EA. So since you don't have a carry, E will be 0 and this sum will be stored in A. Right now the contents of E is 0 and A is 10111. Now E A, Q and SC. So what is the content of E? Now it is 0, and now A contains 10111, Q contains 0011, and sequence counter contains the value of 5. So after performing addition, you have to perform a shift right on the contents of EAQ and decrement the sequence counter. Now we perform shift right on EAQ. So when you perform shift right, this E contains 0 and this will be shifted here. So it becomes 01011. So this MSB will be shifted, LSB will be shifted as MSB of Q. It becomes 11001 and this 1 will be rejected. So you are going to reject this 1. Now you are going to decrement the sequence counter. It becomes 4. So you are performing a shift right as well as you're performing SC minus 1. Okay, in this step. Now, sequence counter, next step you're checking, you're going to check the sequence counter. Sequence counter is still not equal to 0. So now, again, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, and 4, right? So what is the Qn now? Again check Qn. Qn is 1. So when Qn is 1, again you have to add A plus B. So for this is your content of A, add it to B. What is the value of B? 10111. So it becomes, so when you add it here, so if you see here 1 plus 1, 1 0, 1 plus 1, 1 0 plus 1, 1 1, 1 0 plus 1 1, 1 plus 1, 1 0, 1 plus 1, 1 0, and 1 plus 1 1 0. So when you are adding it here, you get a carry, additional carry 1 plus 1. That carry will be stored in E flip flop. Okay, and this it will be the same 0 0 1 and 4. Now next step you have to perform a shift right operation. So perform a shift right, it becomes 0. This 1 will be moved here, so it becomes 1 0 0 0 1, and this will be moved here 0 1 1 0 0, and this 1 will be rejected, and you are going to decrement your sequence counter to 3, right? Now again you are going to check the sequence counter. Still it is not equal to 0. So we will continue here. So my E, A, Q and so we'll continue here. The contents of E is 0, 1 0 0 0 1, 0 1 1 0 0, and the sequence counter is 3. Now we are going to again check the qnth bit. Now the qnth bit is 0. So in a flowchart, when qn is 0, you have to perform a shift right on the contents of E, A and Q, and you have to decrement your sequence counter by 1, right? So I'm performing a shift right, it becomes 0 here, 0 1 0 0 0, this 1 will come here, 1 0 1 1 0, and sequence counter becomes 2. Now again check the sequence counter is still not equals to 0, so you have to check again the qnth bit. 1 0 1 1 0 and 2. So what is qnth bit? It is now 0. So when it is 0, you have to again perform shift right on the contents of EAQ and decrement your sequence counter by 1. So perform a shift right operation. Here you get a 0. Here you get 00100, and here Q register you get 01011, and sequence counter becomes 1. Now you have to again check if sequence counter is 0. Since sequence counter is still not equal to 0, you are going to check qnth bit. 01011 and 1. Now what is Qn? Qn is 1. So when Qn is 1, what you have to do? You have to add A plus B. So this is the content of A, and what is B? 10111. Add them. 1 1 1 plus 1 1 0 1 1, and there is no carry, so E is 0, and 01011 and 1. Now perform. So here you are performing EA implies A plus B. So now you perform a shift right on EAQ and decrement your sequence counter. So now perform a shift right. It becomes 0. This becomes 01101. This becomes 0, sorry, 10101, and this becomes 0. Now since the sequence counter is 0, you have to, so since SC is 0, we come to end. We will have to stop the process. And whatever is in A register and Q register, that is your product. So what is your product? So what is the content of A register now? 01101, and what is the content of Q? 10101. So this is nothing but, if you convert this, you can check it with the previous example we have done. So here what is the 01101? 10101. So the same answer you are getting it here. So which is nothing but it is equal to 437, right? And sign bit, it is already stored as 0. So it is positive sign. So this is how we perform a sign magnitude multiplication with the help of an example. Thank you.